Hi friends, I'm Akil Kumar. Now I'm going to explain about the working principle of three-phase induction motor. And it is important to know the working principle of three-phase induction motor and the terms in the three-phase induction motor clearly, because the 70% of all industrial and commercial applications are three-phase induction motor, and we need to know the basic principle of induction motor, because in the point of our exam and also in the point of our interview, so we need to know the induction motor functionality clearly. So now I am explaining about the three-phase induction motor. Basically, three-phase induction motor works on the principle of Faraday's laws of electromagnetic induction. Induction means injecting of the flux in the rotor, and Faraday's laws of electromagnetic induction states that whenever a relative motion and current carrying conductor placed in a magnetic field, and it will experiences a force and which tends to move the conductor, and in that way the injection of the flux in the rotor will be done, and the rotor rotates with according to the direction of the RMF. And how this RMF will be get in the induction motor means, induction motor here it is a stator and stator winding, and it is a rotor and it is a shaft. And whenever the three phase supply is given to the induction motor, three phase AC 50 Hz supply will be given to the induction motor, a flux will be created in the stator winding, and that flux will be rotating in nature, because the three phase supply has a phase displacement and phase difference in the supply itself, and that is why flux is rotating in nature, and the technical term as RMF, rotating magnetic field, which runs with a synchronous speed, that is ns equals to 120 f by p, and the speed of this RMF will be synchronous speed 120 f by p, and it will be the maximum speed depending upon the frequency and number of poles used in this machine. So here we have a rotor and rotor winding. According to the Faraday's laws of induction, there should be a relative motion between the flux and the conductor. And since here we get the relative motion as like, since it is RMF, rotating magnetic field, means it is a rotation and it is a standstill in the starting position, right or not? It is a rotating and it will be standstill. There will be a relative motion between the RMF and the rotor, and in this concept a flux will be generated, and which creates a force on the rotor conductors, and which tends to move the rotor in the direction according to the RMF. And in this way, here we get a term slip, and it has a major importance in the induction motor. What is slip? Slip is simply a deviation. Slip speed is defined as the speed difference between the synchronous speed and rotor speed. Okay, here I have written ns minus nr is nothing but slip speed, and slip is defined as ns minus nr by ns. Usually we calculate it in the terms of percentages into 100. So as I said, a force will be created on the rotor, and which tends to move the rotor. If the force created on the rotor is maximum, that is maximum force on the rotor conductors, and it attains a maximum speed, right or not? That means ns speed, synchronous speed, because RMS speed is ns, and if we get a force on the rotor is maximum, it attains ns. And there if the rotor attains synchronous speed, there you observe one thing, RMF speed is ns, and if the force is maximum ns, the rotor speed will be ns. There won't be a relative motion between the RMF and the rotor speed, and in that condition slip is zero, right? Slip is zero, and there should be a no relative speed, and Faraday's laws of electromagnetic induction principle is not working out. So rotor of three-phase induction motor start decreasing its speed, and in that condition there will be no connection between the RMF and rotor does not follow the stator field RMF. So whenever it decreases the speed of rotor from synchronous speed to some certain value, again there will be a relative motion is will be created between the stator RMF and the rotor. Again rotor attains a deviation, and the Faraday's laws of electromagnetic induction, since there will be a deviation, it again working out, and again the rotor tends to move according to the direction of RMF. In that way rotor continues to rotating with respect to RMF. There should be a slip should be there for getting relative motion and for proper functioning out of the three-phase induction motor, unlike synchronous motor. And in this way the functioning of three-phase induction motor will be worked out, and there should be a slip for working out, um, and by this speed we get a mechanical output, and from the shaft we connect to the required load, and it will be does the application point of view. And in this way it is a important importance of slip will be defined, and in this way three-phase induction motor will be working out its principle, and it will be clear in this way, understanding in the concept in this way, the manner of the slip and synchronous speed and rotor speed. And these are the only basic terms in the three-phase induction motor. And still if you have any doubts in the principle of three-phase induction motor, you can comment me. And thank you for watching this video, friends.